Hello and welcome. In this lesson, we're going to talk about a Swift construct that is going to allow you to write code that says, if this, then that. Now this easy to use but powerful syntax is going to allow you to express logic at a whole new level. But before we dive into that, just in case you're new around here, hi, my name is Chris and welcome to Code with Chris, the place to be if you want to learn how to make an app. Fun fact, I learned coding because of a mandatory class in school. How about you? Did you learn coding because of school or was it something else? Let me know by leaving a quick comment below, and on your way down there, if you wouldn't mind, please give this video a quick thumbs up. It really helps me out, so thank you for that. All right, with that said, let's dive right in. All right, so I've got a brand new playground here. I want to show you how if statements work before we apply it to our war card game project. All I have here are a couple of constants, actually more than a couple. I have a bunch of constants with different simple values, some integers, strings, and Boolean values. And I want to use these constants to demonstrate how if statements work. Now again, the if statement is very powerful because it allows you to run code based on some conditions. So I'm going to use these constants as my conditions. Let's first take a look at a basic if statement declaration. I'm going to type it out first and then I'll explain each of the parts. So you start with the if keyword and then you put some sort of value or condition that evaluates to a Boolean result. So I'm just going to put E and I'm going to open up a pair of curly brackets, and inside here I will just print hello world. All right, and that by itself is the most simple if statement. As you can see, starts with the if keyword and then followed by either a Boolean value or some sort of code statement that evaluates to a Boolean result, followed by a set of curly brackets, and inside the curly brackets you put the code you want to run if the condition is true. In this case, E is false, right? So it's not going to run that code because it doesn't evaluate to true. However, if I changed this E and I was testing F instead, then this code would run because it evaluates to true. Now it can get pretty crazy because you can chain these things together. So one of the ways you can chain them together is using and that's a double ampersand. So let me just indicate that there. And how this works is if you write F double ampersand, let's say G, then now you're testing both conditions. And because you're using and, both conditions have to be true in order for this code to be run. So in this case, because F and G are both true, right? True and true means true. Okay, and another example is you can use or. So these are double pipes. The pipe key, a lot of beginners, they're not sure how to press it. On my Mac keyboard, this key is right under the delete key and right above the return key. And it's the character on the backslash key. So I have to hold down shift and I have to hit backslash to get that pipe. So double pipes. It might be different on your keyboard. This is or. Okay, when you use an or instead of an and you're chaining together two conditions like that, you're saying if either condition 1 is true or condition 2 is true, then run this code. So for instance, F and G are both true, so that'll definitely run this code. If I do F and E, let's say E is false, remember, this code will still run because at least one of the conditions is true. Now again, this can get pretty crazy because I can keep chaining it. I can keep doing ors, or I can even throw an and in there. So let's do that. But this sort of gets confusing now because this can be read in a couple of different ways. Is it E and G and then or F? Or is it F or E and G? Do you see what I'm saying? So for if I put brackets around these, this might make more sense. If I do this, that's saying if F is true or E and G are true, then run the code. However, I could also put brackets around it like this. If F or E is true and G is true, then run the code. So you can use brackets, rounded brackets, to help you differentiate which conditions to evaluate first. All right, so far we've been using just the Boolean values, but there's still more I want to show you with the syntax for an if statement before we go on to looking at integers and strings. So along with the if statement, you can also extend that if statement to test another condition, because this is just testing one condition, right? You can then, following the closing curly bracket of the first code block, you write else if, and then you write another condition. So let's say else if E, then put that, else if G, and then do that. So what's going to happen here is it's going to test this condition. If this evaluates to false, it's going to then test the next one. It's going to cascade down. If this is false, then it's going to go down to the next one. At any point while it's checking these conditions, if one of them is true, then it's going to go into that branch. It's going to run that block of code, and it's going to skip the rest. So this allows you to test, in this case, 3 different branches or pathways, and only choosing one, the first one being true. But keeping in mind that it checks these branches from these conditions, from top to bottom. So the first one it hits that is true, that's the branch it's going to go on down. And finally, there is also another feature of if statements. There can be a sort of catch-all branch. If none of those conditions above are true, then you can have an else code block. So this code block runs at the very end if none of the conditions were true and it didn't execute any of those branches. So this is sort of like your catch-all or fail-safe. And again, these are all optional. You can have one else if, you can have no else ifs, you can not have any else ifs, and you can just have an else. So if this condition isn't true, then it's just going to come down here. Right? So this if statement is really powerful. The syntax is really simple to understand, but it gives you so much flexibility in which code statements to run depending on what is happening inside of your app. Okay, so I'm going to undo this so we can see sort of like a full-fledged if statement here. And I'm going to show you how maybe integers or strings can be evaluated as conditions. Now, in the example so far, I've just been referencing Boolean values, and that's simple. But working with other data types like integers and strings, you might have to use those in an actual statement in order to evaluate, to get a Boolean result, right? For example, instead of G, which is just a Boolean value true, let's use A. In order to evaluate a Boolean result, I have to use a comparison operator, right? So I can use greater than if A is greater than 0, right? This can evaluate to a true or false. And aside from greater than, here are a couple other you can use. So greater than, less than, you have greater than or equal to, and you have less than or equal to. And then there's equality. With equality, you don't use a single equal sign because that's for assignment. As you can see up here, we are assigning these values into constants. To compare equality, you use a double equal sign instead. So I can say down here, does A equal 0? And of course it doesn't. So this statement here is going to evaluate to false. And because this is an AND operator, both of these conditions have to be true. And because this one is false already, then it's not going to come into this branch. Anyways, we can change these as well. So, if B is less than 3 or 4, and if C is equal to 10. So those are some examples of comparison operators that evaluate to true or false. Now for strings, you can also do that. You can evaluate D, for example, as a string, and you can test if it equals hello. So that's one thing you can do with strings. You can still use greater than or equal to. For example, if we had let h equals world, and we can say if D is greater than H. So we can do that. In this case, it's going to compare the H with the W, and because H is not greater than W, because it comes before W, then this is going to be false. One more interesting thing I want to show you is the use of the exclamation mark. So this one, it basically flips the Boolean value. So if G is true, right? If I put the exclamation mark in front of it, it's basically going to flip the Boolean value. So G is true, I have the exclamation mark, it's going to turn that into false. So it's not going to run this. You could put it in front of this, for example, and A does not equal 0 because A is 1, as you can see up there. But having this in front of it is going to flip that to true. And then now that I think of it, you can test inequality as well, so not equals. And so I can test if A is not equal to 0, which is true, but then because I have this exclamation mark in front of it, it's going to flip it to false. So lots of flexibility here, and this is just an example, right? So it doesn't have to be this complicated. Now I want to go back to our war card game and use the if statement to determine which card is larger, and then increment either the player's score or the CPU score. All right, so here I have the war card game project, and if you take a look at this part here where we were updating the score, we were simply incrementing the CPU and player score with each dealing of the button. Now that you've learned about if statements in the Xcode playground, I'm sure it's very trivial for you to implement it so that you're comparing player rand versus CPU rand, seeing which number is bigger to determine which score to update. Now, because we labeled our assets correctly, 2 being the lowest and ace being the highest, having a value of 14, it's very trivial to compare. You just compare that ending number, right? And essentially that is the random number. So if you think you can do this, pause the video right now and try it out for yourself. You'll learn a lot, I promise. Even if you give it a shot and you don't get it, the lesson is going to stick that much more. So go ahead and pause the video, try it out, and then unpause it and watch me do it here. All right, so welcome back. Let's implement this if statement to see which card is bigger. So I'm going to start with if, and I'm going to first test if the player's number is bigger than the CPU's number, right? I'm going to use greater than. If that is the case, then I am going to increment the player score. Otherwise, I am just going to increment the CPU score. Now, I don't care about ties, and that's why I'm not comparing equality between the two random numbers, but you could definitely do that in your version if you'd like. Actually, there is a problem with the way that I'm doing it here. The CPU has an unfair advantage because in the case of a tie, the CPU does get the score, right, using this else statement. So therefore, I kind of do have to test the other case. So I'm going to test else if CPU rand is greater than player rand, then CPU score plus 1. Otherwise, if those two conditions are not true, then it's a tie and I don't want to do anything. All right, now let's try this out. So I'm going to hit live preview again, and we'll just do it right here in the canvas. I'm going to hit deal. So 14 is definitely bigger than 5, so the player gets a score. Jack is definitely, well, that's an 11. It's greater than 3. 4 is greater than 3. So it looks to be working correctly. Congratulations, the war card game is complete. You've learned how to build user interfaces, how to code in Swift, and you've completed your first app. Think back on day 1 of this 14-day challenge. How did you feel back then? Were you nervous? Did you think you could do all of this? And now look how far you've come. How do you feel about app development now? Now, I've tried to make this as easy as possible to understand, and I hope you were able to gain some new skills. If there's one thing I could really use your help on though, it's with user testimonials. You see, I haven't been asking people and I don't have very many, and it would help a lot for people to hear from actual learners like yourself about how this challenge affected you. This would really help me grow my brand and in turn help many more people discover that they too could learn how to code and make apps. Full transparency, your testimonial might appear on my website or on my social media. So if that's okay with you, simply visit codewithchris.com/14day and it'll bring you to a page where you can record your testimonial right from your browser. Don't worry if you don't know what to say. I have a question for you and you can just simply answer it. It won't take you more than 2 minutes. Thank you so much, whether or not you can help me with that. I really appreciate you learning with me and having stuck through this challenge. Now I know I'm making this sound like the end, but really it's just the beginning of your app journey. In the next lesson, I'll tell you what are the next steps and where to go from here. All right, thank you so much for the testimonial and I'll see you in the next lesson.